I made an assumption today that you have some idea of what DFD and Stride are, but don't worry if you're completely new to this whole threat modeling business, and welcome, and hopefully you will be able to pick up enough to engage with the exercises. And I've done a lot of threat modeling trainings and consulting, and frequently people hit an obstacle saying, we've learned the technique, but it sort of assumes you do it before you started coding, you need a greenfield project, and we already have lots of existing stuff. How can we do threat modeling? We cannot stop and just catch up with everything we've developed up to now. So collaborating with all the people who had this problem, I came across a technique which I hope is useful, that allows you to identify manageable chunks for your threat modeling session, so you can start on this journey without feeling overwhelmed, and you don't need to catch up with 2, 5, 10 years of development before you use a threat modeling technique. So that's the goal, how to pick something for each threat modeling session that you can usefully do, whether you are a developer that works with your peers, whether you are a security engineer that tries to engage developers. You can get people for an hour and sometimes for half a day, but realistically, almost nobody gets in their company saying, let's take a week to catch up with all the threat modeling we've missed. So the goal is to learn how to do something useful with the times we have in real world on a non-greenfield projects, which hopefully resonates with lots of people. So let's start with threat modeling. 4 questions. If you came across them, know them. If not, what are we building in the software world? To do a threat model, we need to understand the structure of the software we are modeling, and a good, useful way to do it is to decompose the architecture using data flow diagrams. When we have these diagrams, we can reason about what can go wrong with this architecture using Stride, which is a mnemonic for different threads that are applicable to the elements of a diagram. And it's just a mental aid to start generating these threads. You can go beyond Stride, you can do free-form brainstorming, but in lots of cases, it helps to have the kind of Stride scaffolding. And then what are we going to do about that? We found all these threads, how we are going to mitigate them. That is not something we will cover today. There are all sorts of techniques for that. And then it's a process that works best in kind of continuous improvement approach. We need to ask ourselves, did we do a good enough job? How we can do threat modeling better next time? What did we miss? And all that. So your typical continuous improvement approach. We will mostly focus on the first 2 questions today. So data flow diagrams, if you looked at pre-work, great. If not, let's see if we can do a quick refresher. Is my cursor visible when I go around this diagram? Cool. So there are specific shapes that are used in DFDs for threat modeling. The most important one is a circle, which denotes process, not necessarily a process in a computer science sense, like memory, operating system process. Any logical process that receives data, does something with data, sends it somewhere else. Any logical entity like that that does active manipulation of data is process, and we have circles for that. We have squares or rectangles sometimes that denote external entities, which can be either human users who are external to our system. We don't control their behavior. We don't control what they do. They will do all sorts of unexpected and interesting things. And also third-party systems. Again, we don't control how they are set up, whether they are securely developed, securely configured, whether they've been owned this morning, and now we are communicating to them without being aware that they're now attacker controlled. So anything that's external to us will be this kind of square. There is another shape which I don't have on this diagram called data store, which is typically two parallel lines. And this is not necessarily a database. Typically, it's anything that holds data passively, a file, a registry. Sometimes it makes sense to denote devices like that, various sensors. Anything that holds data, we will put as a data store in our diagram. And the very important bit, trust boundaries, which can be boxes or lines, it doesn't matter. Now, trust boundary, if you're not familiar with it, it can be a bit confusing. It doesn't denote protection. So sometimes people who are used to network diagrams think, oh, it means I have a firewall around this. No, it doesn't mean that. It's the opposite. It's more about danger than protection. It means that the data flows that cross trust boundary go between elements with different level of trust. So, for example, we don't trust users to the same degree we trust our backend. So these are all the elements that go into DFD. And data flows, their direction indicates write or read. So that's about DFDs in 60 seconds. Now, what is this story? This is based on a real life story. Let me introduce you to it. So irs.gov is a portal that the American tax revenue service built for people to do their income tax online. And this diagram talks about one user journey in this story, which is user registration. So how does it work? The user goes to this portal. The user supplies their social security number, which is a unique number that Americans have, and their email. This portal sends this data to an external service provider that presents the user some challenge questions. And these challenge questions are based on pieces of information that the government already knows about you, such as your name, your date of birth, and other knowledge-based sort of authenticating pieces of data. If the user answered challenge questions successfully, then the portal checks that this social security number hasn't registered yet. If it hasn't registered, then the user gets user ID and can start interacting with its tax affairs. Or if the user failed challenge questions or such a user already exists, then the registration will be rejected. This diagram represents this user journey. Now, immediately in this first illustration, we should look at how the threat modeler who created this diagram dealt with complexity. Because this diagram focuses on the data flows that are new to this user story we are building. Everything else, we're not building IRS computer systems from scratch. They already have lots, and it's incredibly complex. And we put all this complexity in the box. We called it backend. And somehow this new portal talks to these old systems, but we don't care at this point because for our story, this is not where the focus is. And this technique is basically the key to my workshop today. If for some reason you drop off, you can already take away something useful. Put complexity in a box in your diagram and focus on the data flows and components that the team is building or going to build. Now, as I said, this is based on a real story from several years ago. And there was a big security flaw in this design. The question is, can we find it using threat modeling? By the way, Shining, I see something appeared in the chat, but if it's a question, will you please tell me, because I can't monitor chat at the same time. Okay.
So the question is, external provider, will the external provider be handling that verification? For example, ABC company's application will be getting SSN and email.
So external provider doesn't know about SSNs, but this data flow between portal and provider gives maybe JSON with all the pieces of knowledge for challenge questions.
Hi, Irini. Cristiano here. Just a very stupid one. Is this all protected with HTTPS?
Yes. So the communications are protected with HTTPS.
Okay, and what is that fourth data flow from human user to external service provider about name, date of birth, and other?
So the service provider will tell you what's your name, and you will have to type your name in, and what's your date of birth, and you will type a date of birth in, and it will compare it to the data it received from the government server. And if your answers match what the government already knows about you, then you will get an account registered. Maybe we need a hint here. Let's focus on the data flows I highlighted. And another hint here that the slide is called spoofing. So think about spoofing.
Basically, anyone who can enter any SSN can find the email of another person and enter any SSN and find out if it does exist or not this way.
So yeah, spot on. Spoofing, if you didn't come across Stride, spoofing stands for pretending to be something or someone you are not. So how spoofing will work here? Just sending random SSNs probably will not work because it's a long number. But if somehow I managed to steal your, to learn your SSN, maybe just stealing a paper letter that was going to your post box. Then, if you are still not registered on this portal, I can register with your SSN and any email. All these challenge questions people will learn from social media, for example. Essentially, what stands between an attacker and identity theft here is just knowing the SSN number. If they know it, they can register with arbitrary email, somehow learn challenge questions, and they can control your tax affairs. So if the attacker gets lucky, you are due some kind of refund and they will get your money. If there is no refund, the attacker can still mess up your tax affairs that it will take years to sort it out. And thousands of people were impacted by this vulnerability, which is a design level vulnerability that could be spotted with some quick threat modeling. So to me, this example focused on obviously how useful it would be to do threat modeling before we write this feature, but also to show you how to tame complexity by putting it in the box. Let's do quickly another example to do with tampering. So this is also a real life story. What happened here? Compromised router. The client sends request for updates. Because the router is compromised, this request doesn't go to legitimate server, it goes inside to an attacker-controlled destination. Malicious update is served and installed on the privileged account, and then this PC is completely owned. You can mine Bitcoins, you can turn it into a node in distributed denial of service attack, whatever you need. Why I think threat modeling is very relevant to this story? Because let's imagine we are client team. We are writing a software that sends requests and receives updates and installs them. We don't know what router is used. We don't know anything about these compromises. But if we had threat modeling session like that, and we started doing stride and we reached tampering, we would ask ourselves, what if our response has been tampered with? Shouldn't we somehow validate the integrity of update before we install it as a privileged account? So if we are client team, it will get us thinking. If we are server-side team, again, it will get us thinking. We may not even know that these guys don't validate digital signature if we attach it. So this is more about threat modeling helps in an environment where different teams build different components to catch these assumptions that maybe they've done without talking to each other and lead to serious vulnerabilities, again, on design level. If there are questions, let's take questions. If not, let's jump to our Miro board. Our first exercise, canvas called exercise 1, group 1. Group 2, this is your canvas, exercise 1, group 2. Each one has shapes library above. So either copy, paste, or Control D duplicate, drag it to the canvas. If you need to make canvas bigger, I will make it bigger, don't worry. So the exercise is on top here. It's a very simple, old-fashioned app. There is some information, and in a typical threat modeling situation, you will probably want to ask clarifying questions. So I will play sort of product owner who can answer clarifying questions. So our goal for this exercise, let's build a DFD for this architecture with, if you discover complexity that's not relevant here, put it in the box, hide it.
Here's our data flow diagram. So here we just we identified 3 different external entities. So one for a registered user, one for an anonymous user just browsing the content, and then one for an admin user since they have specific functionality for themselves. And we all have it crossing, we all have all 3 crossing a trust boundary to the web browser, which we have here as a process. And then we have 2 data flows that are going over through the corporate data center trust boundary. And those 2 data flows are to post content, and then also just getting content from the web server. And then inside of the corporate data center trust boundary, we have the web server where everyone's accessing, and then the SQL database or the data store where the web server is adding new content and also pulling the content to share with users browsing it. I think that covers everything.
Yeah.
We have a question for you, Ivan. Do you usually design different, like for example, on this example, would you design 3 different systems, meaning 3 different web browsers, because of the fact that they don't have the same functionalities, they don't allow to do the same thing, or not? What are your best practices about this?
So it depends what feature we are working on. For example, if we started with, I don't know, MVP with only anonymous users, and then we add registration, and it's really a focus of our upcoming iteration, how this new type of user works, then you will represent it separately because you won't really focus on these data flows. But if, for example, the focus of our team next iteration was something completely different. For example, if I wanted to say, as a team, we are now adding some kind of analytics on our web server, then the whole client side is not in focus. We would put it in one element and say, this is not relevant to our current functionality increment. So it really depends what you're focusing on. For this diagram, because story mentioned 3 users, I think it was absolutely correct to represent 3 users. How we know even the difference between them? Maybe there will be different controls there. For example, maybe admin has 2-factor authentication. So we will have a little extra control. Let me get here. So I will put additional control. Oh, sorry, I'm on the wrong diagram. Yeah, I will put additional control on admin user, and it will signify admin has 2-factor authentication, unlike the other 2 users.
Oh,
By the way, I put in a chat a link to the blog that explains these little tags. It's not our focus today, but I just find them useful. We use them a lot. So admin will have control CO1. We will put it in a table. There is our little table that says CO1 is 2-factor authentication, and C2 is HTTPS everywhere, and you know, that sort of thing. So as we go and we document our assumptions, we also build a useful table of controls. Yeah, so let me go back to what I was talking about. We started with a story. We used elements in the story. So the 3 users mentioned, it's absolutely correct to put them together. There was one thing that no one fell for. Sometimes people think admin, because they are working for the company, people put admin inside the corporate data center trust boundary. But the story says actually admins can connect from anywhere. So it would be wrong for our story to put them inside the trust boundary. They have to see it outside because they connect from anywhere. They connect over insecure hotspots for all we know, and it's important to our threat model. So I think group 1 spot on. Group 2, do we want to present your solution?
I've got one
really quick.
question. Oh,
Yeah.
You go first.
yeah, this is Hadley. I was just going to ask, would the web browser be a process or would it be an external entity? Because with each user, like the corporate doesn't have any control of the web browser that's being used or anything about that.
It's a good question. Again, it will depend if we want to focus on client-side threats or not.
Okay.
Probably we do in this case because there is authentication involved. So we do want to discuss browser being compromised and whatnot. when we do things manually like that, it almost doesn't matter because we can still discuss whatever threads we want. When you use tools, then it becomes important because tools have rules inside them that probably follow stride per interaction. And there are more threads applicable to processes than threads applicable to external entities. So if you use tools like Microsoft or any other commercial tools, then it becomes important to get the shapes right. But when we're doing whiteboarding or virtual whiteboarding, it's less important because we will still discuss whatever we want to discuss.
Okay, thanks.
And then just one quick one. I think the answer is no, but I just want to clarify for the admin accounts, since they have their own functionality, should that be represented as its own data flow diagram, or rather, sorry, data flow, or no?
Oh,
Is that
okay. I didn't answer it properly the first time when it was the right answer. So in any kind of real system, there will be layers. You will start with a super high level context view, which is probably what we've done here. And then there will be series of, you start breaking down this architecture. You will build multiple diagrams for different use cases. So there will be a separate diagram for administration and probably a separate diagram for registered users if they do more complex things. And there will be a diagram for how we update software on our server, with our DevOps and all that. So multiple use cases typically will require multiple diagrams, but it's nice to have a high-level overview before you start decomposing.
Okay, thank you. All right, I'll stop sharing.
We have three external entities: the anonymous user, the registered user, and the admin user. Differently than the other team, we didn't consider them separately from the web browser because we are assuming that they access via a web browser. So basically, they will access from the web browser and get on the web server via the web browser, but probably they can also access via curl or via command line or via other means, but it might not be the same experience as the web browser. So we're just assuming that they can access via web browser. That's why we didn't add the web browser in the middle. And then as part of the data flow, we have created three separate data flows based on the type of request they can submit to this web server. So the anonymous user can only browse, so that would be read-only. And we try to identify that. The registered user is also allowed to post content, so that would involve post requests and things potentially related to tampering later on. And the admin functionalities, we expect those to be things that will allow to access areas of the application which are for higher privileged users. The corporate data center trust boundary separates the internet to our corporation, and then there is another trust boundary internally that assumed that the web server was on the DMZ or at least internet accessible, and the database is in an area of our network from a logical perspective, which can be accessed only by database admins or users as part of that specific project. From a data flow perspective, we didn't know anything about the technology, but surely there would be a query from the web server to the SQL database, and then a response that would be shown directly on the application running on the web server.
So just wanted to highlight something. It's almost perfect, but you didn't arrange it that way, I promise. The differences between two diagrams, does it mean that one of the answers is wrong? No.
Yeah, it's a model.
Exactly. It's a model. All models are wrong, some are useful. But also it can reflect a different focus of the teams. So for example, the diagram that group 1 produced makes it easier to reason about client-side threads, what's in the browser, all that. But the diagrams that group 2 produced will let us focus maybe on threads inside our data center. Is the network segregated enough? Who can access the network? Can you sniff on it? Are they running at the same level of privilege? Should we have a trust boundary? Can database be accessed by other components within this trust boundary? Do we want it? It all depends on the feature that we are going to work on and what is relevant to this feature, and have we hidden the unnecessary complexity. Like, what I mean is, in this diagram, if I say another machine, we can start reasoning. Can they go directly to the database? Do we want it? Do we want database to be only accessible from one specific server? And how we will achieve it? We will have a allow list, we will have internal firewall, all the good things. So the diagram helps us to focus on the things that we are actually building. So it's great that they worked out differently.
Yeah.
Quick question here, Erin. So here in the group 2, right, like we don't have like a trust boundary created for the users going to the data center. Ideally, should it be there? Or
We do. This box is a trust boundary. So the data flow called browse, it crosses a trust boundary.
okay, like data corporate trust
Yeah,
boundary.
it doesn't matter if it's a line or a box. As long as the data flow crosses red line, it means trust boundary.
Now all these users have different privileges and everything. Will there be a one trust boundary or multiple of those?
I think for simplicity, it's one trust boundary. How we will reflect that the users have different permissions. There are different ways. So one way you can do it, for example, with listing assets. So for example, anonymous user doesn't have any assets, not even password. Registered user, there is an asset that we want to protect, and that's the user's password. So we will start talking, how do we know it's not in browser storage in such a way that others can steal it? How do we know it's not in transit? So this user has assets, and admin has yet different assets. Maybe admin has a YubiKey or some corporate application installed for two-factor. And then we can talk about how we protect these assets to prevent privilege escalation, for example. But I think 3 trust boundaries would be an overkill to represent that.
Got it. Thank you.
I have an additional question.
Yeah.
Okay. I would like to know, Irene, what do you recommend between the 2 representations about the web browser? Let's assume, for example, that to connect on the web server, you will need an MFA. For example, for the registered user or even for the admin user. But let's focus on
MFA?
an MFA, a multiple
okay.
authentication that will grant that will bring a certain level of security and prevent another user who has stolen the credentials to connect to the web server. Let's assume that this registered user is a bad actor. He's a threat actor, I mean. And he will use his web browser, the F12 functionality, which is a developer, and it will try to modify the parameters which are sent back to the server. He will do some tampering on the information he sends on the server, for example, to allow to steal information about other users, for example, or whatever would be the case related to this tampering action. To visualize, to better visualize this specific kind of attack, is it better to have the web browser on the diagram or not?
Excellent question. Depends on the team's overall maturity. So when I look at a diagram with a browser, which hopefully I'm sharing, I can start talking about this registered user being potentially malicious. I will say this user is a threat actor. What can they do? So this crosses trust boundary here, which implies our code that runs in the browser doesn't trust the user. Maybe we will do some validations. And if you are this kind of developer, you know that whatever validations you've done in the browser will not stop an attacker from actually tampering with the inputs and posting malicious content on this data flow. So we still need to deal with potential injections or whatever's password stuffing or whatever this threat actor was trying on a server side. So depending on the maturity of the team, it may be helpful to have browser on a diagram, and then you will say, whatever validation we've done here, we need to duplicate server side. Or in a more mature environment, typically teams are not going to discuss injection every time there is a traffic to web server. They will say, we are using frameworks that prevent injection. And we all know server-side checks are the only checks. So depending on the team. Typically, in a slightly more mature SDLC environment, you don't want every time there is SQL database to start going, oh, what if this data flow has SQL injection? Because you say, no, we only use parameterized queries, we use frameworks. We don't want to spend precious threat modeling time when we put 5 expensive developers in a room talking about things that can be captured with tools and automation. And we want threat modeling to be a higher abstraction level than that. I hope it was,
Okay.
it was an answer.
Yeah, thank you so much.
We have another exercise. So in threat modeling, it's very important to understand point of view from which team we are doing the threat modeling. It helps us to tame complexity and put everything that's not our responsibility in a box. So our point of view is via a QA team, and it's a real life story. My friend approached me when he became the lead of this team to ask how to do it, and we were able to build a useful threat model in 30 minutes, so hopefully we can do that as well. So QA team in a smart car manufacturer, not Tesla pirates, a responsible smart car manufacturer. And there is an existing setup, let me explain it to you. The car has software, obviously. This software collects data on some kind of internal storage within a car. Periodically, it uploads this data to cloud storage. And this all exists. We are not threat modeling it because it's crazy amount of software and architecture and it's not our responsibility, and we don't have time. So strong hint, this complexity we want to put in a box and kind of ignore. We want to focus on what our team needs to do in the next iteration. So sort of here and now. Let's do here and now. What our team needs to do. We have some specialized testing software that another team builds, manages. We need to run the software in a dedicated test environment. We know how to authenticate to the software, and we know what it does. It will access this global cloud storage of car data and download a small sample to this test environment for testing purposes. What we want to achieve is when we do this setup, we are not compromising the security of our company. We are not making the existing situation worse. So what we want is to build a diagram that focuses on this next iteration in our team's responsibilities. We don't want to boil the ocean. We are not solving embedded software problems. We are not solving cloud software problems. We are focusing on this story. And we will do this exercise on the same basis in 2 groups. We have 2 canvases for group 1, for group 2. I will jump between groups with Shuning's help and answer questions. And let's get on with it.
Yeah, so we when we started the modeling, we started drawing the car, but quickly found out that wasn't maybe the focus on this exercise. So we started then drawing the cloud data store, which is in the cloud trust boundary. Then we have the own testing environment where we are running the specialized testing software, which the QA and is building and managing the testing software, and then it accesses the cloud storage and then sends the samples back and then stores it to a data store.
Yeah, here's what we had. Yeah, we started out thinking a little bit about the car, right? Talked a little bit about, we have an entity for the car. It's not really in scope for what we're working on, but the car does have kind of onboard storage, and we have that in its own little trust boundary there for the car, because I think the trust will change as you leave, obviously, the vehicle. We then talked a little bit about the cloud provider. It's a different trust boundary because we're uploading data from there, and we have kind of a process that shows the upload of data there to the cloud environment. We're not really concerned with how that's happening, but we know that the data is being stored there. And then we move over to the right side. We do have the testing team, right, who is accessing our testing tool in its own dedicated environment there. So another trust boundary. They're authenticating with their username and password to get into that tool. And we also have a process for downloading some sample data into the testing environment, however that may be occurring. So those are kind of the 3 main areas that we focused on. I think that's pretty much it.
Yeah, and I think the diagrams are pretty similar in both teams. Again, maybe, yeah, very similar. So group 2 chose to show separately the downloaded data, which would allow us to ask questions. What are the permissions on this file? Who else can access it? And all that sort of good things. What's the other difference? And group 1 chose to focus on authentication as a separate process. Again, might be useful if you want to analyze it in depth to have it as a separate element. And also an interesting difference that you guys chose to put this team outside of environment trust boundary, but here the test team sits inside the trust boundary. Again, there is no right and wrong, but it probably expresses slightly different approaches and how we would reason about things. So essentially, building a good diagram that tames complexity helps us to keep our brainstorming focused, because say we've done a diagram, and the next thing we will do, we will grab this panel, we will put it maybe under a diagram, and we will start brainstorming. And if you can tell a team in your workshop, we are focusing on this and this data flow, then you have a focused workshop that ends on time, which is very valuable. And find some threads that you can actually control the outcomes of. Because if you remember the manifesto, it says threat modeling is good if the outcomes are valuable to stakeholders. So you will find things that you can actually do something about in the next iteration. And it's great because I like short cognitive loops, not finding something that we will need in 3 years' time, and equally not finding the mistakes that we've done 20 years ago, because you can only be upset about it, but not likely to be able to fix it quickly. So it will find actionable things, it will be time boxed, and both of these diagrams, I think, identified very early on that the software that runs on the car is completely irrelevant to us. We are not interacting with it directly, so we don't need to analyze these threads. How is it stored? What happens if there is a disk overflow inside the car? Will it kill the driver? Not interested. We are only working with cloud storage, so we will focus our analysis on what is this testing tool, how we authenticate to it, how it stores data locally, is data secure in transit, because it's a valuable data from real cars. It needs to be absolutely secure in transit. It will be pretty bad if we allow man in the middle or something like that. Why I like other column? Because not everything falls neatly into stride. For example, you can say, does the car, if I connect my phone to it, there will be my messages there, my contacts, my address book, and I download all this. Is it making me, what is it called in GDPR, data processor or whatever? So we will have privacy threats that don't fall neatly into stride, but we can capture them in this other column. Yeah, so we've done this with my friend, and it got him from a state of being completely overwhelmed. I have this problem. How do I focus on security when it's not even my direct part of my direct duties, to being able to focus on specific things? Does my company have secure templates where I can spin this testing environment in our approved cloud and be reasonably confident in how it's configured and deployed? Does the tool support secure transport mode? Do I need to configure it, or is it good enough by default? Does the tool support length of passwords that we feel happy about? All the questions that are in my area of control, and I can make some useful decisions instead of worrying infinitely about my giant company and 20,000 developers that work for it. So that was the exercise. if we go back to the PowerPoint, no, it will not work. I will stop sharing. And I will start sharing this slideshow again. So, conclusion. Incremental is great, useful, I love it, but we will not be able to get away with doing only incremental. It's a great starting point. It fits with how modern Agile teams work in story-based development. But at some point, we will need to tackle this legacy monster because it's all very nice joking. I don't care if a car kills a driver, but actually I do care. And at some point, I will need to look at the whole system and deal with legacy threats as well. But it's a great starting point because we build up skills. We touch all the moving parts of our software. It's better than sitting in front of a giant blank canvas and starting to think about everything. Incremental threat modeling can fit any time box. You can always say, let's pick one data flow and do stride for this data flow in 15 minutes. And how we can make it fit this time box? We focus on new and change things. Everything else we call, this is legacy blob. I think I mentioned it when I was chatting to one of the teams. A super useful approach is to think, we are working on a new feature. Are we making our security stance worse? Are we opening new attack vectors? Did we increase our attack surface? Did we maybe weaken some controls? And we focus on not making the existing situation worse. We gradually build our threat modeling muscles, and we can then tackle the existing parts of our software. And the third tool you can talk about, in any kind of complex organization, different teams are responsible for different components. You can say, this sounds realistic, but it's not our problem right now. Again, it doesn't mean you hide it from people. You can have a useful problem description and talk to the other team after your workshop, but it's not your focus right now when you've got 10 expensive engineers in the room. So with this technique, as I said, you will start using incremental, but eventually you need to build a whole. Why is that? For two reasons. Because in software, the system is bigger than the sum of its parts. I can have secure component A, secure component B, and the way they talk to each other make the whole thing insecure. So we can't just get away focusing on bits and pieces that we are touching. We will need to tackle the whole. So reason one, the system is bigger than the sum of its parts. Reason two, in security, it's not good enough to say, I looked at the new and changed things, and the old, the legacy software, no one is complaining, it means it's okay. It doesn't mean it's okay. There are security bugs that are found 5, 10, 15 years after they're introduced. So it doesn't work like that. Depending on the organizational situation, you can start building the big model in parallel, or you can wait for several cycles until the relevant people are comfortable with threat modeling. And the last, most important conclusion, if you take one thing out of this, don't wait for the start of the greenfield project or the next perfect version, because it's a trap. Software developers often fall in this trap, thinking, okay, this one we were forced to do quick and dirty, next one we will do perfectly. It never happens. You need to start secure development practices today, and you need to start threat modeling today, working on the imperfect project or version that is the current reality. So these are my conclusions. Yeah, I shared it in the chat. take it. It talks about Draw.io. It's a tool that I was struggling with today, but it's a useful tool. You know where to find me. I am on TM Connect forums along with lots of other very knowledgeable people. Thanks for great participation. It was an absolute pleasure to do this workshop today.